Hello everybody, welcome to a new video. Today we're going to be discussing chapter 19, doors and windows.
And we are team 3.
Let's get started.
Alright, to begin, we're going to start talking about the types of windows. So first, fixed windows, they actually have no operable components. So they are the least expensive and least likely to leak air or water. And operable components basically means that they don't have any moving parts. So next, single hung and double hung windows have one or two moving sashes, which are the frames in which the glasses are mounted. A sliding window is a single hung window on its side, pretty much. Projected windows is basically a category that kind of oversees casement, awning, hopper, in-swinging, and pivot windows. All of these types of windows must have stronger sashes since there's only one side that pivots either inward or outward. Hopper windows are more common in commercial buildings than in residential buildings. Like awning windows, they will admit little or no rainwater if they're left open during a rainstorm. Here we can see basic window nomenclature through a cross-section of everything that is at play within our windows. So I guess I can start with the interior casing and the head jamb at the top, the exterior casing on the outside, and then we have the sash, the stool and seal, and then finally the apron at the bottom. So glazed units installed in roofs, such as skylights, are especially constructed and flashed to remain watertight in their sloping or horizontal orientation. I remember in one of the videos, or in one of the chapter videos prior to this one, we talked about flashing and how it helps windows, how it helps openings, and other apertures like that. Skylights can either be fixed or operable, so they can either just be where there's no moving parts or some moving parts. And then moving on to doors, large glass doors may slide in tracks or swing open on hinges. Different to sliding doors, French doors may offer a more welcoming appearance, but they are prone to air leakage along its 7 edges. The terrace door kind of offers a small solution to this leakage, but it can only open up half of its area since only 1 out of 2 doors can open. And kind of going back to glass, it must be washed at regular intervals if it were to remain transparent and attractive. And most operable windows are designed to allow washing of the outside glass surface from the interior of the building itself. Wood is the traditional frame material for windows. It is a good thermal insulator and rarely changes size in regard to temperature. If the wood is free of knots, it is also, or it'll be stronger than pieces of wood that have knots. However, when moisture content changes, wood can either shrink or swell, and it also requires repainting or touching up every couple of years. And when wood is wet, the windows are subject to decay. They can either rot or decay. Alternatives to this problem are short lengths of defect-free wood that are actually finger jointed and glued together. So while they do kind of provide a solution to decaying wood, or wood that is not as strong, they are not that attractive, so they're often covered with wood veneers on the inside, and then plastic or aluminum cladding on the outside, in order to appear kind of visually appealing, if that makes sense. Moving on to aluminum windows, well, actually the material itself, aluminum, when it is used in window construction, it's strong and less vulnerable to moisture damage in relationship with wooden windows. And the good thing about metal aluminum windows is that durable factory finishes can eliminate the need for periodic repainting after the window is installed. So kind of going back to the wooden window, it might need a touch up every couple of years, but aluminum does not need that because when it's in the factory, durable finishes are applied to the actual aluminum. But a downside to aluminum is that it can conduct heat pretty fast, pretty rapidly. So unless there is a thermal break present, the window will be thermally inefficient and fall at risk of what we call condensate or frost. These types of windows are also more expensive than wooden windows as well. So those are just kind of the disadvantages of aluminum windows in comparison to wooden windows. And then finally, I'm going to be talking about plastic windows. So straight off the bat, plastic windows, they never need painting. I'm sure that a lot of us have certain possessions that are plastic, maybe our phone case, maybe a decoration that we have on our dresser, and we can see that all of these materials never really, for the most part, need painting or touching up. So it's pretty much the same thing for windows. So yeah, they never really need to be touched up, at least as much as wooden windows do. And they are also fairly good thermal insulators, like wooden windows. So they also cost less than most wooden windows. The disadvantages, however, is that they are not as stiff or strong as other materials for windows, and they can expand with increased thermal energy. So take like maybe a cutting mat. That's a type of plastic, and we all know as architecture students that if you leave your cutting mat out in the sun, it will begin to warp, expand, contract at certain parts. So plastic windows are the same thing as well. Again, they can also expand with increased thermal energy. In other words, when it gets a little bit more hot. PVC, I'm sure we've all heard of PVC, is one of the most common material choices for plastic window frames. And then also, fiberglass windows can result in strong, stiff pieces that are relatively low in thermal expansion. So fiberglass kind of offers a little bit of a solution to the problems that regular plastic windows have. However, fiberglass windows are more expensive than those made of wood or regular plastic. Thank you.
Okay, so hi guys. I'm going to be talking about plastic building construction, and this is a continuous part from Joel's section. And this section talks about plastics that are composites that are combined with non-plastic materials such as laminates, melamine, formaldehyde, and polyester concrete and particle board. Plastics can obtain their shape through processes such as extrusion, pultrusion, molding, and calendering. If a heating process is done, then the techniques can be blowing forming or vacuum forming. Plastics have several advantages, such as being low in density. They are also cheaper. They have a good surface and appearance qualities. They are little affected by water or biological decay, and they do not corrode. They have low thermal and electrical conductivity and have a high strength to weight ratio. The disadvantages are the synthetic plastic delivered chiefly from oil, coal, and natural gases, which are all non-renewable resources. Examples of plastics with advantages and disadvantages are polyvinyl chloride, which is basically PVC, and neoprene and PTFE. Next, we're going to be talking about steel and bronze. An advantage of steel is that it is used as a frame material for windows. There are steel windows that can be done in factory of steel coated with a long-lasting paint coat. They can also be galvanized or stainless steel. There is also bronze windows, which are made of natural patina finish, and both of these materials are conductive of heat. Here we're going to be showing you some pictures and examples. The next section talks about muntins. Muntins are window sashes divided into thin wooden or metal bars in between smaller lids mounted. There are 6/6 is a typical double hung window that had its upper and lower sashes each divided into 6 lids. A way to do these is by constructing sashes with multiple smaller sized double galvanized lids held within a muntin. The least expensive way is using grids of imitation wood or plastic muntin bars clipped into each sash against the interior surface of the glass. The next section is galvanizing. Galvanizing is accepted in the mildest climates because of its low resistance of heat flow and moisture condensation. Double galvanizing is the minimum that will meet the energy code requirements in most climate zones. And here's an example of that. The next section talks about installing windows. Before installing windows, there is a rough opening in the wall that flashes with material that will prevent air and water leakage. Some of these flashings materials are self-adhere flashings, liquid applied flashings, or sheet metal flashings. The rough opening is the wall is usually a little bigger than the window, and the space in between is called shim space. There are nail flake windows that come with a continuous metal or plastic flow around its perimeter. There is also a non-flake window that are placed within a rough opening with slits inserted into the shim space. Both windows are fastened and sealed. The sealing joint or air sealed is installed all around the 4 sides of the window between the rough opening flashing and the back edge of the window frame. There's also a head flashing that is installed above the window for extra protection, and the inside of the window is covered with the trim components, and here's a picture of that. The next section talks about sustainability and windows and doors. They point out energy performance. Windows have an impact on thermal performance of the building enclosure. What's recommended is to use an improved window with the thermal conductance of U-0.25 that will result in a combined thermal performance of R-11. Proper installation, air sealant, and the inclusion of natural daylight can be a benefit energy efficient for the occupant and its well-being. They also talk about building a material life, which is cycle impacts, and over 95% of the aluminum building and construction scrap are recycled into new aluminum products. There is little recycling of scrap wood or doors. And in the United States, plastic windows and doors are not recycled. The next section talks about doors. Doors can either be interior or exterior, and depending on its function, they are resistant to sound, fire, or smoke barriers. For exterior doors, there are solid entrance doors that mostly are made of glass, storm doors, screen doors, or vincular doors, also revolving doors. For interior doors, there is a greater variety of models, and we are going to show you some right here. They also talk about wood doors. At one time, all wood doors were made of wood. For simple buildings, primitive doors were made of vertical planks or C-bracing, which were the common ones. For finished buildings, there was a stile and rail doors that gave us sophisticated appearance. Stile doors can be made of solid wood or composite materials with veneer faces and edges, and we're also going to show a picture right here. Today, flush doors consist A flat, veneered wood faces assembled over a variety of core types. For exterior and higher quality interior applications, these doors are made with solid cores made of wood composites, solid lumber strips, or fire-resistant mineral cores. For a lighter weight, there are a halo core doors with an interior grid made of paperboard or honeycomb or spacers. A commercial door can be made of 7 or 9 layers in total, which would be called 7-ply and 9-ply, and the more expensive can be the 5-ply, which is an architecture quality door with a sturdy core. In the next section, Daphne is going to be talking to you guys.
Hello everyone, and we're going to continue with chapter 19, doors and windows. So now I'm going to talk about steel flush doors. Flush doors with faces painted sheet steel, called hollow metal doors, are most common type of doors in non-residential buildings. Metal doors and most non-residential wood doors are usually hinged to steel frames called hollow metal frames, which are also formed from sheet steel. Knockdown KW steel frames arrive on the construction site in 3 separate sections for the 2 jamb and head and are assembled in place into the previously prepared wall opening. Welded steel frames arrive on the construction site pre-assembled and welded at the corners. Hollow metal door frames installed in masonry walls are sometimes with gypsum or Portland cement grout to improve sound deadening or strengthen the frame and its anchors. The sheet metal used in the manufacture of the hollow metal doors and frames can be varied in thickness and achieve varying levels of durability. And here's a few examples on figure 19.21. So moving on to fiberglass doors. Doors with fiberglass reinforced plastic or FRP skins and subframes are manufactured as hollow core doors and Fulinic coat paper or plastic honeycomb cores. Or they can be manufactured with solid insulating plastic foam cores. FRP doors can be flushed or molded to resemble wood grain steel and rail doors. FRP doors with insulating cores offer thermal performance superior to the wood doors. FRP doors can also be manufactured to meet a wide range of commercial and institutional requirements. Fire doors. Fire doors, that is, door openings with fire-resistant rated walls, most of themselves be fire rated. The door and frame are rated according to the period of time for which they are able to resist specific time and temperature conditions, as defined by the NFPA 252 standard methods of fire test of door assemblies, or by similar tests defined by underwriters' laboratories. This is figure 1923. Gives fire resistance rating for doors opening in rayed walls as required by international building codes. For example, a door and frame in a 2-hour rayed exit stairway enclosure must be at least 11.5 hours rated. An opening in a 1-hour exit stairway enclosure must be 1 hour rated, and an opening in a 1-hour rated exit corridor, 20 minutes, 1/3 hour rated. These labels must not be painted over during construction so that the fire rating of the door can be verified during the future building inspections. Glass used in fire doors must itself also be fire rated, and it will not break and fall out of the opening for a specific length of time when exposed to the heat of the fire. Maximum size of glass may also be restricted, depending on the fire classification of the door and the type of rayed assembly into which it is installed. Egress doors and accessible doors. Many doorways act as components of a building egress system, or the path of the occupants take when exiting a building during a fire or other emergencies. Building codes require that such doorways be sufficiently wide to allow occupants to exit in a timely manner, with the width of any particular door dependent on the number of occupants served. Their international building codes require egress doors serving 50 or more building occupants, as well as the doors serving space classified as hazardous occupancy. Even when locked, egress doors must remain readily open from the side for which the occupants may approach the door when exiting. Some egress doors are required to be fitted in panic hardware. Doorways along building roads designed to be accessible to people with disabilities must meet requirements for minimum width, ease of operation, maximum height of threshold, and adequate clearance for approaching and opening the door. Moving on to door hardware. Door hardware is selected by the designer independently from the door itself and installed on the construction site. Swinging doors are usually hung with 2, 3, or 4 butt hinges, depending on the door's weight. Door operation, either a round doorknob or flatter lever, is provided. However, whatever accessibility is a concern, levers that are more universally operable must be used. Pre-hung doors arrive on the construction site with the doors installed in their frames, often with most of all additional hardware accessories already in place. Installing the doors. The installation of the doors and frames in the wall rough opening proceeds much like the described earlier in the chapter for windows. In the case of interior doors, no flashing or other weather sealing related components are needed. Other window and door requirements. Safety considerations in windows and doors. To prevent accidental breakage and injuries, glass and large lids within windows must be made of safety glazing material. In many residential occupancies, building codes require at least one emergency escape and rescue opening in each bedroom, consisting of either a door to the exterior or a window that can be opened. Structural performance and resisting the wind and rain. Many performance aspects of the window and exterior doors are defined in North American Fenestration Standard Specification for Windows, Doors, and Unit Skylights, NAFS, officially designated as AAMA/WDMA/CSA. Standards establish minimum requirements for air leak age, water penetration, structural strength, operating force, and force entry resistance of aluminum, plastic, and wood frames, window doors, and unit skylights. Thermal performance. The National Fenestration of Rating Council, or the NFRC, defines a program of energy efficiency testing and labeling based on 2 standards, the NFRC 100 and the NFRC 200. The most important properties included in these standards are thermal transmittance, U factors, and solar heat gain coefficients. U factors represent the overall thermal transmittance, or whole product heat loss of complete window, door, and skylight products. The AAMA/WDMA/CSA and the NFRC standards are referenced by the International Building Codes and National Building Codes of Canada, making them one of the factual standards for selection of most North American building fenestration products. Moving on to acoustic isolation. Acoustic doors are made with the core materials that are effective at reducing sound transmissions through the door itself. Especially important are the acoustic seals, which must ensure a continuous seal around all 4 edges of the door when the door is closed. In acoustic windows and glazed acoustic doors, glass is double or triple glazed and made with thicker lids and fabricated with wider air spaces in between the lids than in a typical glass unit. All measures that reduce sound transmission. Impact resistance. The International Building Code, glazed opening in open-worn debris regions must meet standards. For resistance to high wind forces and debris impact-resisting openings, also sometimes referred as the hurricane rate openings, are fitted with a laminated glass with a heavy interlayer of PVDB or polyvinyl butt rail, and other similar rough viscous plastic. And lastly, the blast resistance. 2 federal standards for designating blast-resistant glazing systems are used. One, published by the Department of Homeland Security Interagency Security Committee, and the other one, the Department of Defense. That is it for me. Thank you.